All right, that was kind of fun. That was just improvising and goofing around and seeing what I can come up with. All right, so I've got one last part of this section to go through. So what we're going to be looking at is just basically some trig functions where you have to use your calculator to solve these. Everything I've done so far, you've kind of used the unit circle. So all these things right here are going to have to do with your calculator primarily. So one of the key things you have to be able to do on this that's real important is understand, the possible quadrants you're in and the idea of reference angles and interpret what's going to be coming out on your calculator. So what we're going to do on this example 8 is we're going to find all real number solutions. And again, when I say that, you're looking for a formula. And if I say real numbers, you're talking about radians. So it's important you understand where the directions are leading you. So actually, what we have to do on this first one is we'll have to get our calculator out. And you want to make sure that you're in radian mode, if you aren't already there. And then we're going to go back and we're going to use the inverse trig functions on this. So you start this problem by doing a couple of things. Okay, first of all, to me, it's real important that you know what quadrants your angle is going to be in. So see, this is a positive number. So the sign takes on positive values 2 places, in quadrant 1 and also in quadrant 2. So you have to know those 2 things and then be able to interpret what's going to come out on your calculator. Okay, and then essentially what we're going to do is we're just going to do the inverse sine of 0.35 in radians, and that should give you a quadrant 1 answer. Okay, so I'm going to go ahead and just go inverse sine of 0.35 and record what I get. This will be in radians since I'm in radian mode. Okay, so what I'm getting is I'm getting x equals, and I'm going to round these things to about 4 decimals as I go through these. So I'm going to say 0.3576, 3576, round the 5 up to a 6 like that. Now what that's giving you, see, is that is giving you a quadrant 1 reference angle right there. Okay, now I want to show you something on this too. Like if you wanted to convert this to degrees to help you understand where you are, well, what you do is if you multiply this by 180 over pi, like we learned how to do, then this would actually give you about what that angle is. So that's about a, roughly about a 20.5 degree angle is what that is. So you're in quadrant 1. You're not used to thinking so much about radian measures and what quadrant they're in. Another good thing to look at is if you do pi over 2. We know pi over 2 is 90 degrees. Well, see, this is 0.5 is less than 1.5, so you can tell that's in quadrant 1. All right, so what we do is we're going to get 2 answers on this problem. We're going to get quadrant 1, we're going to get 0.3576 radians is going to be what the value of that angle is going to be. And then if we go to quadrant 2, we got to use this reference angle. So if you're in quadrant 2, you have this same reference angle of 0.3576. And what you have to do is you got to do this. You know that halfway around the circle is pi less that reference angle. So you're going to do pi minus 0.3576 to get approximately what that angle x is in quadrant 2. So I'm just going to take pi minus the 0.3576 radian measure, and then this will give me the second answer, quadrant 2, which is about 2.78, and let's see, let's take that up to 40 to get the second answer of that problem then. All right, now what we're going to do is we're going to find all real number solutions. So what we need to do is we need to get a formulaic answer to this problem. Then I'll show you how to check this and interpret this on your calculator. Okay? All right, so we would write the answer to this problem basically like this then. We would just say set of x such that x is approximately equal to 0.3576, and then we would still say plus 2 pi k Okay, because another lap around the circle, of course, would get you back to that same angle. And then we also say x is approximately 2.7840 plus 2 pi k, and then we have to state that k is indeed an integer. Okay, so that would be the answer to this problem would be that. That's how you would write all those real number solutions on that then. Okay? All right, so basically a kind of a quick way to tell that you're right on this problem. I'm going to clear everything off of here. I mean, you could graph it, but you don't really have to. So if you wanted to go through and just check the answers, you could do this. You could just say, okay, the sine of 0.3576 radians, we need to see if that's about 0.35, and notice it is, so that's accurate. The other answer was 2.7840, so you could just do sine of 2.7840 and see if you're approximately at 0.35, and you are. You're off a little bit because we rounded our answers to the problem, so that would be it. And the meaning of this 2 pi k, for instance, if you did the sine of 0.3576, your quadrant 1 answer, and if you just added 2 pi to it, notice what would happen is you would get the same answer. Okay, and then if you went up to 4 pi, because what you would be doing is you would be doing integer pi's, so it would go 2 pi, 4 pi, 6 pi, and so forth, because k would be, just some number. So you'd have 1 times 2, 2 times 2, 3 times 2, and so forth. So you would just get the same answer over and over again when you do that then. So you can easily verify that you have the right answer on these problems by just doing some simple calculations. Okay, so I'm going to kind of leave that up there just for checking purposes for you to review that then. Okay, so the next thing I'm going to do is I'll move on to the second problem, which we'll do basically the same way. What I always recommend that you do on these problems is immediately figure out what quadrants you're in. And notice on this one we have a negative valued tangent. The tangent is negative 2 places. It's negative in quadrant 2, and it's negative in quadrant 4. Okay, and we've learned how to do those things before. And what we're going to do is the same thing we did on the last problem. We're going to do the inverse tangent of negative 3.5, and then we'll just do that on the calculator because we pretty well have to do this in the calculator. When I was a trig student back in the 1980s, calculators were kind of new. These scientific, we used to have to go back to the back of our trig book and look these things up in a table and do something called interpolation. So it's much better to be a trig student in the modern world. You can learn a lot more from what you can do on graphing calculators and understand concepts better too, I think. So I'm going to do that on the graphing calculator, and again we'll just round this off to 4 decimals, so we get about negative 1.292, and then I'll round that up to 5, 2925, okay, like that. Now what we need to do is we need to do the 2 quadrant answers. So we need to get a quadrant 2 answer, and we also need to get a quadrant 4 answer, kind of like what we did in the last problem. Okay, and then we'll be able to write this down in a solution. Although the tangent, I want to show you that really when you're writing a formula, the only thing that's going to matter is one of the answers, okay, because they're going to be 180 degrees apart anyway. So you need to understand that what happened on the calculator is, since the tangent is negative in quadrant 2 and 4, the calculator is programmed when it does an inverse tangent to give you a negative angle in quadrant 4. So that reference angle is going to be this. Now reference angles are always positive, by the way. So what you're going to end up having, your quadrant 2 angle is going to be 1.2925 also. So the calculation you have to do in quadrant 2 is you have to go halfway around the circle, which is pi, less that reference angle, which is positive, by the way, and then you would get what x is approximately equal to. So I'm just going to go pi minus the 1.2 0.925, like that, and that will give me approximately 1.8491, and that would give you the quadrant 2 answer. Okay, quadrant 4, you're going to do this. All the way around the circle is 2 pi less the reference angle of 1.2925. So you want to do that on your calculator, and we'll get approximately what that is then in radians. So 2 pi minus the reference angle, and let's see, that's 2925, and that will give me approximately this. So let's say 4.99, and then we'll take that to 0.7. Okay, and a couple of things I want to show you on this that are real important. Those are two answers that you have on the interval 0 to 2 pi. But a couple of things I want to show you is that, remember the period of a tangent is pi. So I want to show you, if I was to go through and take this first answer, 1.8491, and if I was to add pi to that, notice what happens. Okay, you're going to actually get that second answer anyway. So when we write our formula, this is the way it always works on a tangent. You don't have to worry about that. So the answer to this problem is simply going to be set of x such that x is approximately equal to 1.8491. And now it's going to be plus pi k, where k is an integer. Okay, and then that will be the final solution to that problem then. Okay, so that's it. All right, and again, this kind of a thing, you can do all the calculation. You can do the checking real easily on your calculator like this. So I'm just going to clear off what I have and show you. So really all I got to do is just take the tangent of my first answer, 1 plus 8,491, and let's see if we don't get about negative 3.5. Okay, and see we do. And if I did the tangent of that first reference angle, 1.8491, and I add the period to it, which is pi, well, I get the same thing. Okay, and if I did this, if I did the tangent of 1.8491, and if I subtracted the period from it, I get the same thing, and I get that over and over again. So the formula is just saying that's your initial answer, and just keep adding or subtracting the period over and over again, and you would get these answers infinitely, okay, and both laps around, clockwise and counterclockwise around the circle. So that's essentially what you want to do to check your answer then. Okay, all right, so I'm going to put you to work on a couple of problems. These are just things you want to do on your calculator and see if you can interpret correctly. So I'm going to go ahead and pause the video, let you work on these, come back and see if you did them right. And remember, you're writing a formula on these problems. And please just take a minute to check your answers when you get the answer. Okay, so if you want to check your answer, this is what you should have come up with on these. And of course, make sure you're in radian mode. So problem number 1, you would want to write your answer like this. This is rounding to 4 decimals, is a pretty good standard. You would get set of x is approximately 0.5988 plus 2 pi k, and also x is approximately 5.6844 plus 2 pi k, k is an integer. So what I did is I just did you have to understand that this is a positive number, okay, and the cosine's positive in quadrants 1 and 4, so you have to get that aspect down in order to do this, and that's really one of the key parts of this problem. Use your calculator. If you do inverse cosine, you get this. I rounded to 4, so that's your quadrant 1 reference angle. And then that would also be your quadrant 4 reference angle. So to get the quadrant 4 angle, it's 1 lap around the circle, 2 pi, less that reference angle would give this. Okay, and then you're just adding on that period on that, 2 pi k, to both of those like that. If you want to do a very quick check on the calculator on this problem, then essentially what you would do is this. You just, really all you got to do is do the cosine of the first answer, 0.5988, and that gives you about 0.826, okay, and then you can do the cosine of the second answer, 5.6844, and that'll give about 0.826. That's really all you got to do to check and verify that you're right on this problem, see, okay? All right, so that's it. The next one, you have a tangent, okay, you have a positive number. You need to know that the tangent's positive in quadrants 1 and 3. Again, I did the inverse tangent of 2.9 and got a reference angle of 1.2387, which gives you the quadrant 1 reference angle, okay? And it turns out on this that it doesn't really matter that you figured out the quadrant 3 angle anyway, so once you do this on the calculator, then you're pretty much ready to write your answer. So you'd have set of x is approximately 1.2387 radians, plus pi k. And remember, the period of the tangent is pi, so that's why we use pi k. So I want to show you a couple of things on this, just kind of remind you of this. You can check on your calculator very easily. You just take the tangent of your first answer, 1.2387, and notice you'll get about, I put the wrong thing in. Okay, so let's do tangent of 1.2387, and you get about 2.9, okay? And the reason we don't have to get this second answer, which is 4.3803, is because if you did the tangent of the first answer, the quadrant 1 answer, and added the period to it, you get the same answer anyway. Okay, so see, this formula will give you that quadrant 3 answer anyway, so you don't have to write both of those formulas. Okay, so that's it. All right, so that's it. The key thing is knowing the quadrants that you're in. All right, so let's move to the next page. The last page on this, I'm going to do one example where we do the quadratic formula, and then I'll let you do one of those as well. All right, so what's going to happen, the first thing that we're going to do, this would be an equation that does not factor. You could attempt to factor that, but you wouldn't get anywhere on that problem. Okay, so in that case, then what you want to do is you want to do the quadratic formula. But before you do the quadratic formula, you have to do what we'll call a trig substitution. And what you're going to do basically is you're going to do this. You can pick any variable you want to. I'm going to pick, I don't know, like p or something like that. So I'm going to just call that, p is going to be equal to the sine of x. And that's where you ought to put your substitution, is in that middle term. And remember, a quadratic equation has the standard form ax squared plus bx plus c equals 0. So that middle term is going to be like the bx part. Well, this part would be p squared. So p squared would just be sine squared. And then you're ready to do a trig substitution. So what we're going to do is this equation is now going to become 2p squared plus p minus 2 equals 0. You can use any letter you want. I just randomly kind of picked p for some reason. I like p, I guess. Right, so what I'm going to do is I'm going to solve this equation then. So in the quadratic formula, a is the coefficient of the squared term, b is the coefficient of the middle term, and c is the last term. And you want to use the signs whether they're plus or minus. So the quadratic formula, the solution of this variable b would be given by the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac, and then all over 2a. All right, so you got to know the quadratic formula to put this together. So we're just going to plug in the numbers. So we have negative b. Let's see, b is 1. I recommend you use parentheses everywhere there's a variable. So when you set this up, it's kind of something squared minus 4 times something, all over 2 times something. That's a good way to learn how to plug into a formula, is just use a set of parentheses where your variables go. Okay, so what would go in then is b squared, so b is 1. You'd have 4ac, a is 2, c is negative 2, and then 2a A is 2. Now we're going to mostly just work this out on the calculator, but before we do that, let's take this as far as we can. So that would be -1. This would be plus or minus 1 to the seconds 1. Notice you have two negatives, so that's a positive. So this would be 8 times 2. That would be positive 16. And then the denominator is going to be 4. Now what we're going to do is we're going to take this one more step, and then we're going to go to our calculator to complete this problem. So what we ultimately get is the value of P is -1 plus or minus square root of 17 all over 4. All right, so that's the first thing you got to do. You got to do that trig substitution, and then in order to use the quadratic formula. But that's not the answer to this problem. A lot of times students think that's the answer. No, it's you're not done yet. You still got quite a bit to do. So what I'm going to go ahead and do is I'm going to kind of take this in two directions. Okay, so the first thing I'm going to do is I'm going to do -1 plus the square root of 17 over 4. And then I'm going to do -1 minus the square root of 17 over 4. And I'm going to just do that on my graphing calculator and maybe round to like 4 decimals like we've been doing. Okay, so I'm going to just kind of move this over here, and then we'll go ahead and get that done then. Okay, all right. So let's put this in the calculator. Okay, and you want to put this in your calculator pretty carefully. It's best to just use parentheses. So on this first one, I'm going to go parenthesis -1 plus square root of 17, and be sure you're out of that radical, and then close the parentheses divided by 4. So you want the calculator to do the numerator before it divides by 4. And then we'll just round that to 4 decimals and write down what we have. So that's about 0.7807. Let's take that up to 7808. Then we'll do the next one the same way, parentheses -1 and minus square root of 17 and divide by 4. So we're going to do that. And then that will give about -1.28, and let's take that up to 2808 like that. All right, so that's step 1. Step 2 is you got to remember that if you go back to this substitution, P is sine x. So actually, that P is sine x. All right, so what you end up doing is you get this equation. You get two equations. You get sine of x is equal to this, 0.7808, and you get sine of x is equal to -1.2808 like that. So you got to do the inverse trig function on your calculator. So I'm going to solve these two equations. Okay, first thing I'm going to do is we need to know what quadrants we're in. So let's do this first one. What we're going to do is we're going to do x is equal to the inverse sine of 0.7808. All right, now this is a positive number. So remember, the sign is positive upstairs in quadrant 1 and quadrant 2. Okay, and then the calculator is going to give us a reference angle. So if I go inverse sine of 0.7808, then that will give me the reference angle that exists in quadrant 1, which is 0.8959. And then that same reference angle would be in quadrant 2. So we're going to get two answers on this problem then, see. All right, so the quadrant 1 answer is going to be x is approximately 0.8959 radians. That's what came out of the calculator. The quadrant 2 answer is going to be, well, you have to do a calculation. Halfway around the circle is pi radians less the reference angle. Okay, so we need to do that. So x, we need to just take the calculator and take pi minus the reference angle, 0.8959. We'll round this to 4 decimals. Okay, so I'm going to get 2.2457. Okay, so what we have then is we've got a quadrant 1 answer and a quadrant 2 answer of this problem. Okay, all right, so we got that. Now we need to go over to this one. Now this one, you don't have to do anything on your calculator if you're observant, but what we would do is we would do the inverse sine of negative 1.2808. I would hope that you already know what's going to come out on the calculator. Well, let's find out in case you don't know. But if I do inverse sine of negative 1.2808, look what happens. Does that surprise you? Well, I hope it doesn't, because you never on the unit circle, remember the sine's the y value, so it never gets smaller than negative 1. So that's an error, so there's no solution on this. So that means we're ready to write the answer of the problem. All right, so that's not going to give us anything. You still got to look at it, though. So that means when we get the final answer, we just write the final answer like this then. Okay, so we say set of x, and we say x is approximately 0.8959 plus 2 pi k, and then comma, we say x is also approximately 2.2457 plus 2 pi k, where k is an integer. Okay, so that would be the final answer to that problem, and it would be written like that. Okay, so what I want to do is I want to close off this problem like I've been doing most of these, just by checking it on your calculator. This is a good example of something that's probably just as easy to do this on the graphing calculator. So what I'm going to do is I'm going to go back to the problem we're working on. So the problem we solved is this. So I'm going to put in the left side of the equation, I'm going to put in 2 parentheses, sine x squared, and then plus sine x, and then minus 2. All right, you don't have to put anything in y2, but the other side of the equation is 0. That just means we're going to be looking at where y is 0, meaning we're looking at an x-intercept. So I'm going to graph that like that, and I'll slide this over here. Whoops. So you can kind of, that's not what I meant to do. OneNote is so picky about stuff sometimes. Okay, there we go. Okay, so I got to slide it over a little further so it won't mess everything up. Okay, so we got that. Now what I'm going to do is the window. Okay, well, we were solving this on the interval 0 to 2 pi, so I really am supposed to get 2 answers on this problem. So I'm going to go ahead and just set up my window 0 to 2 pi. I'm going to do pi over 2. This is actually a pretty good window that I already have in my calculator, so you could put that in. Okay, and when I graph this, this should show that we get just 2 answers only on that interval. All right, so let me slide this over here and kind of talk about the significance of what's coming out on the graphing calculator. Well, okay, so what's happening is you're getting 2 answers. This answer right here, this one, that x-intercept would be the 0.8959 radians, and then this answer would be 2.2457. Okay, now that would give the exact formulaic answer, but the specific answer would be 0.8959, comma, 2.2457. So in this problem, actually, this is what I was looking for, is this thing right here, because you were asked to solve on an interval, so that's your final answer right there. And all you got to do on your calculator is just trace out those 2 solutions. So if I traced 0.8959, that pretty well should verify that that's correct. See, it's given y is close to 0. If you look at that, 10 to the negative 5, that just means the decimals are moved back 5 places, so it's close to 0. Then if I trace it 2.2457, then that'll verify that answer too. So that's it. Okay, all right, so let's move on to the next problem. I'll let you do this, and then I'll finally close off this very long section. Okay, do the best you can on this. You're going to need to use your calculator. I want you to solve on the interval 0 to 2 pi, and please check on your calculator like I did on the last. Okay, so let's take a look and see if you got the right answer. The final answer that I got was this. There's two answers. There's 1.2996 radians, 4.9836 radians. So if you got that right, congratulate yourself for doing a great job on the mathematics. Mostly this is all calculator and using the quadratic formula. I'll kind of talk through this. If you got it right, you're done, unless you want to watch what I'm doing. So I did a trig sub. P was cosine x. Therefore, p squared is cosine squared x. So you start with those two pieces right there. When you do the trig sub, you're going to get p squared minus 4p plus 1 equals 0. All of this work here is solving the quadratic formula. So you need to look at your arithmetic and see if you got down to this point. 4 plus or minus root 12 over 2. Then I take my calculator and I take this in two directions. I do 4 plus root 12 over 2 to get this, 4 minus root 12 over 2 to get that. Okay, and you want to make sure that you put that in your calculator right. You can kind of look at, if you want to, what I did here. That's the calculations that I did to get those two things. Okay, then what I did is, remember, p is the cosine. Okay, this is the answer to p. Okay, that's what that is. But p is cosine of x. So you set cosine equal to this, and you set cosine equal to this. Okay, what will happen is when you do the inverse cosine of 3.7321, that's no solution, because that number right there has to be less than or equal to 1. It can't be bigger than 1. Okay, and then this one, if you did this on your calculator, when I did the inverse cosine, I got 1.2996. I rounded it to 4 decimals. You need to know that this is a positive number, so you're in quadrant 1 and 4 on a cosine. That's where the cosine's positive. So that's my quadrant 1 answer. And then my quadrant 4 answer is all the way around the circle 2 pi, less that reference angle, gives you that. So those are your two answers that you get to that problem. Okay. As far as doing this on the calculator, if you did this, you would put in y1, you would enter this way. You could, y2 is 0 if you want to do that. All that does is just highlights the x-axis. And then if you trace these two solutions, you're going to find that this solution, that x-intercept is 1.2996. And then this solution right here is about 4.9836, like that. Okay, and then that's how that would go. You can just trace out those two solutions, and then that verifies that you have the right answers. Okay, all right, so that'll close us off on that. Hopefully that'll help you with this last part. I'll get this posted, and good luck on your homework with solving trig equations.